This video we're going to continue our discussion of double integration. I give a formula up there at the top. It's called the reduction formula. I'm not going to prove it, show you where it comes from. You could work on that if you wanted to prove it for yourself. This is a great thing to have in your toolkit as you go further into calc and into DiffEq if you're taking that. Alright, so we are going to discuss another problem involving volume. Notice they gave me this surface. Alright, so that surface is a cylinder. We are missing the y. So this is, if I were to look on the xy axis, okay, here's my, or sorry, xz axis, we'd have a cylinder of radius 4 going in that direction. Now, they have a couple things here. It said z equals 0, so it's only the top part. And then they said y equals 0 and x 0 is 0. This just leaves me to the first octant. So we're dealing with that shape. That's what it looks like on the side. So that would be the whole shape. Now, the other thing they gave us kind of restricts us. This is just a line. You can see this by moving 2x to the other side. I graphed that line there in purple. The x equals 0 and y equals 0 and z equals 0 actually keeps us right there in green. And then it's this surface here on top of that. So it's cut just that way. We're trying to find the volume of that little section. Okay, so the surface, though, is not totally clear on how I'm going to use z. Well, we're just going to solve for z. So this is z squared equals 16 minus x squared. And then if I were to solve, I'd get the plus or minus square root of 16 minus x squared. But our limitations of z equals 0 tells me that's just the positive. Now, remember for integration, we always do top minus bottom or right minus left. Well, this function with the plus is on top, and then we're restricted by this z equals 0. So it's just going to be this function, and we're only going to use the positive, so let's write that down. This is the top, and then this is the bottom. So if I subtract those two, I got that minus 0, I just have that. Okay, let's set up our double integral. My advice for this problem is we're going to write quite a bit, so write small in these sections. Okay, so I have the integral. We're going to set this up. Okay, the square root of 16 minus x squared minus 0, but we don't need to put minus 0 because that doesn't do anything. And then I'm trying to determine which one I want to do first, x or y. So if I look here, top versus minus bottom, it's already set up. We already did it for y. I could do left to right, but I'd have to solve for x, and it's going to introduce some fractions. So I'm just going to keep it the way it sits. Dy dx. So I know y is bounded by, well, they told me y equals 0. And then up to that line, so that's y equals negative 2x plus 2. And then our x's, if we just use the picture, it's x equals 0 to x equals 1. All right, there's our first. Let's go ahead and take our first integral. So x equals 0, x equals 1. Notice there's no y in my integrand, so this is just going to be y times square root of 16 minus x squared. And then we're going to put in y equals 0 and y equals negative 2x plus 2. And then we still have our dx. All right. I'm going to go to the right because we're going to do quite a bit here. Plugging in x equals 0, x equals 1. And then the 0 is just going to 0 out, thankfully. So we get negative 2x plus 2 times the square root of 16 minus x squared dx. Now, right away, you look at that and you're probably, oh gosh, that looks horrible. This is going to be a trig sub. We can use sine or cosine. I'm going to use sine here. And what I'm going to do is I'm going to pick sine convenient to work out with this. That's what I noticed. So something minus 6, some like radius minus x squared with the square root. If that x was a sine or 4 sine, then I could use that Pythagorean theorem identity. So I'm going to let u, or x rather, sorry, x equal 4 sine, and this is where we're going to switch it to u. Right? What happens here, and we're going to start plugging things in, is if I take the derivative dx, I got 4 cosine u du. So we're actually going to replace, let me get rid of this little part here. I have to like write it out because there's stuff underneath it. All right, doesn't matter though. Okay, so that, not there, but here is going to be replaced with that. All right. But also check this out. If I take 16 and I minus sine, and I'm going to go ahead and square it, 16 sine squared u, this thing is equal to 4 cosine u. You can go ahead and figure that out if you want. Subtract your 16 out, replace it with a cosine, a squared, and then take your square root. That's what you get to. That's going to go right here. So let's do some color coding there. This red, this is going to replace that. And then we have one more sub here. This is going to go right there. So notice if I do all of that and I replace everything, everything is in terms of u, except for my bounds, so I can just rewrite my bounds in terms of u. Alright, so the bounds though, if I plug in 0 into this function here and solve, I'm going to get, it's actually the inverse sine of 0. We'll figure that out here in a moment. And then if x was 1, I divide by 4 and then take the inverse sine. So I have the inverse sine of 1 over 4. That's just taking each x and plugging it in here and solving for u. Okay, so now I'm going to go ahead and start replacing things. It's going to get gross. Minus, okay, if I plug in 4 sine u, I got minus 8 sine u plus 2. And then replacing the square root, remember we get 4 cosine u. That's the red substitution. And then the pink substitution, I'm going to get 4 cosine u. I'm going to put that in parentheses and throw du on the outside. So notice everything now is in terms of u, and we're hoping this is going to turn out to something pretty. Unfortunately, it does not. We're going to have to just manipulate quite a bit of stuff. So I'm going to factor out, you see that 4 and 4 there. I'm going to put a 16. Let's go ahead and inverse sine of 0 is 0. Inverse sine of 1/4 is not pretty, so we're just going to leave it alone as that the whole time until the end, and then we're actually going to make a big jump at the end. So this leaves me with 8 sine u, do that a little better, 8 sine u plus 2 times cosine squared u du. Now, cosine u, I see that other sign, and it'd be really nice because I'm really aiming towards that reduction formula. If I could change that to a sine. Well, I can with the Pythagorean theorem. This is negative 8 sine u plus 2, and then this becomes 1 minus sine squared u du. Kind of nice. Right? I'm going to multiply everything out. So I get 16 times u equals 0. We haven't done our integration yet. Sine inverse of 1 over 4. Then I'm going to multiply everything out here. Okay, I got negative 8 sine u. And then I got positive 8 sine cubed u. That's multiplying the first term. The second term, I'm going to get a plus 2. And then a minus 2 sine squared u du. Notice now, I could use the reduction formula for everything. I'm just going to break each one down to help me see it. So I'm going to pull the constants out. Negative 8 times 16 is negative 48. Much bigger than that. That'd be times 3. So what is that? 16 times 8 is 48. Carry a 4, 128. So this is a 128. Integral u equals 0 to u equals the inverse sine of sine u. Right? Plus 128 again of u equals 0. U equals inverse sine of 1/4 of sine cubed u du. Oh, I should move that over. We forgot our du there. Don't forget that. No, that's important because we have different variables. Du. And then the next one, we're going to have a 2 times 16, so it's plus 32. U equals 0. U equals inverse sine of 1/4 of, okay, that's just 1 du. That's that 2 here. That's what we were dealing with. 2 times 16 gets me to the 32 and then leaves me with a 1 inside. And then our last one, I got a minus 32 integral of u equals 0 to u equals the inverse sine of 1/4. And we just have a sine squared u du. Cool. So this is just a bunch of integration now. It's not pretty. I got negative 128. The integral of sine is negative cosine u. And then we run that from 0 to inverse sine of 1/4 plus 128 of, okay, we're just going to use the reduction formula here. So that is, it says put m on the bottom. M was my variable. If you need to go up here and look at it, please do. So m goes on the bottom, so that was a 3. And then we have a negative cosine of u, whatever u was, well, it's u, times sine of 1 minus m, so it's 2u. This is ran from u equals 0 to u equals inverse sine of 1/4. All right, plus the next thing is just our u's, so 3, 2, we get a u, and then we run it from 0 to inverse sine of 1/4. And then our last thing, minus 32, use the reduction formula here. This is, okay, m is 2. Then I got negative cosine of u, sine of u. And that's ran from u equals 0 to u equals, we're here at the edge of my page, inverse sine of 1/4. I made it. Okay. After some work, you're probably going to hate to hear that. But after some work, we can work all that out, and we can get down to the answer, negative 128 over 3 plus 11 square roots of 15, and then plus 16 sine inverse of 1/4. So you can see that sticks around. There's going to be ways to manipulate things to get things where you need them. So give it a shot if you'd like. On a test, I probably wouldn't give something this long on a test because it would take a whole lot of time to get through all of that. But this is as gross as it's going to get. We're going to use tables when we can use them, and the good thing about calculus, as you go up, less memorization, use tables and tools to figure it out.